Hey guys, welcome to an Unreal Engine 4 tutorial. In this one we'll be doing an updated version of a previous tutorial I've done before for a 2D moving platform. In this one we'll be creating a new platform that uses a target point that can be placed anywhere on the X and Z axis. So I'll just quickly demonstrate that. So if I click on the platform, you can see that it has a floating 3D widget that you can place anywhere. So we'll just make it on a diagonal for now. Hit play, eject, and as you can see the platform travels back and forth to the target location. If I quickly go into it again, move the target location, hit play, and you can see the same thing happening. Now this platform is moving to a different location altogether and it's not bound on any particular axis. So without further ado, we'll go into it now. Okay, so the first thing we need to do is create the actor that will be our moving platform. Now, as you can see on the screen here, I'm just using the standard Paper 2D side-scroller template, engine version 4.22. So in the folder I've created called Platform, I'm just going to right-click, add a blueprint class, and I'm going to pick Actor. And I'm just going to call this Moving Platform _BP. Open that up, and as you can see it's a standard actor with a default scene route. So what I'm going to do next is I'm going to go up here and add a new component. I'm just going to type in sprite and I'm going to pick paper sprite. So platform sprite, it's not necessary but just to keep track of where it is. And on the right hand side I'm going to go into source sprite here and I'm just going to type in image. And as you can see, this is the standard sprite that comes as default with this particular template. You can use your own version if you like, but for this tutorial I'm going to stick with this one. So that's basically the visual sorted out. The next stage we're going to look at coding the blueprints to get this thing moving. Okay, so the first bit of code we're going to add into this will be in the construction script, and this will make sure that when somebody places the actor in the world, that it will always be 0 on the y-axis. If you look at the actual template, you can see here on the transform y is 0, so we're just going to add something to make that a bit automated. So what I'm going to do is I'm going to go into the construction script, get actor location, and then on the return value here we're going to split the struct pin. Right click anywhere in the graph here, go for a set actor location, right click on the struct pin, split the struct pin, and as you can see we've exposed each individual axis X, Y and Z. So all we're going to do is we're going to connect X, we're going to connect Z, and we're just going to plug in the construction scripts there. Now what this will mean, if I go into the actual actor itself, if I just drag that in here, it will default it Y is 0 for you. So it's just a quality of life upgrade when you're placing this actor in the world. It will also stop you from the character from jumping on it and falling through because it's on the wrong axis value for the Y. So we'll move on to the next part, which is the logic to drive this to move. Now we're going to add the variables that we're using in this. There's about 9 of them, but bear with me. We'll go through them all now, that way they're ready to just drag in when you need them. So the first one I'm going to add in is target location. And this is the one which will be used to determine where the platform will be travelling to. So on the left hand side here we're going to click on variables, add variable, and then the details panel on variable type, we're going to make that into a vector. And this is going to be called target location. It's going to be instance editable, and it's going to show the 3D widget. Next one, we're going to add a current, so it's going to be another vector which should automatically choose a vector type. Current start location, and I'm going to add another vector called current target location. Next we're going to add in one called location. And another vector called swap. And we're going to have another one called direction. So that's pretty much our vector variables covered. Next we're going to add another variable, but only this time we're going to make this into a float. And this is going to be called speed. We're going to make this instance editable so that it can be set publicly for each individual platform. You can set individual speeds. Next one is going to be called journey length. And finally, this one is going to be called journey travelled. So as you see here, we've got all 9 of the variables, and these will be just basically set in place ready for when we do the implementation. So if you need to just take time, pause the video, get the right types, and then we'll be ready to move into the next part. Okay, so for the next stage we're going to code the event begin play. So the first thing we need to do is we need to get the active location, and what we're going to do is we're going to set that as the current start location to begin with. So you could just hold Alt, or you could right click, but if you just hold Alt on the variable, drag it in, drop it in, and you can see that it'll get a setter. Get the active location, connect it to the current start location, and that's that part sorted out. So the next part, we're going to have to set the current target location. Now this is where it gets a little bit more complicated if you don't understand local to world space. So if I just quickly demonstrate this, if I drag my moving platform BP in here, you can see we've got a current target location. If I select that and move it, what it will do is it will actually move that offset against where the current platform is, but it won't actually give you the proper location of where that target is in space. So we have to take into account the transform location, which will convert it to its local space to world space. So going back into the blueprint, to do that, well, the first thing you need to do is get active location. We're going to drag in our target location, which is represented by the 3D widget. We're going to drag from target location, and we're going to type in transform location. And as you can see, it takes in the transport pin, but what we can do is drag that into there. It'll do a conversion node. And what we want to do now is set the current target location. So select it on the left hand side, hold Alt, drag it into the graph, connect the transform location to the current target location, and then connect that to that. And there we go. So in terms of where the current start location, which is here, it knows where that target location is actually supposed to be in the world, because we've just done a transform inverse. We're converting it from local to world space. And if you hover over the node, it will actually tell you that as well. So the next, we're going to move into the next method, which will be the event tick, and that will make the platform move to where it needs to go. Okay, so we're going to start to code the main body of Blueprint to get this platform moving. So we don't need event type to begin overlap. We'll be dragging it for an event tick. So what we'll do, first node we need to get is hold Alt, get a set location, and we get the current, get the active location. Next we need to drag in current target location. So hold Control, drag the nodes in, current start location, and what we're going to do is we're going to calculate the distance between the current start location and the current target location. So make sure that the target is basically top and start is at the bottom. And from this node, we're going to, well, from a minus node, we're going to type in vector length. This will return a float, and what we'll do is we'll need to set the journey length. So select that, hold Alt, drag that in. That'll set the journey length. Connect that for the time being. Yeah, why not? We'll connect that for now. Next thing we need to do is get the location, get the current start location, subtract the location, or rather subtract the current start location from location, and we'll get a vector length for this as well. And effectively this will tell us how far this platform has travelled. Connect that together, and that's the first part. So I'll just drag it in to make sure it's a bit closer so it's easier to read, or easier to see rather. There you go, and that's the first part. So that's established. As soon as the event tick fires, it'll set the location, it'll get the distance, the journey needed to travel from the start location to the current target location, and it'll also ascertain how far the platform has travelled towards its target location as well. Next, we're going to code what will happen when the platform has reached its end location. So what we need to do is, we've got these two variables that are being set. We're going to basically set a conditional to what happens when the platform has travelled to where it's got to. So it's reached the end of its length, journey length. So what we need to do is, we need to drag in get journey travelled, get the journey length. Again, I'm holding Control just to drag these in. And we need greater or equals float. This will return a boolean, and from this we just want a branch. So if this is true, we need to get the current start location, hold Alt for a swap, and we need to set that as a swap variable just for as temporary. Get the current target location, and we need to set that as the current start location, so that we make the platform go back to its original location. Get the swap, and we need to set that as the current target location. Now, at the end of this, we need to determine the direction. So in order to determine the direction, we need the current target location. So getters, we need to get the current start location. We need to minus vector. So vector minus another vector. And to determine a direction between two vectors, you have to normalize it. So from this node, type in normalize. Don't worry about the tolerance. And we're going to set a direction here. Okay, so just quickly run through that again. So has the journey travelled, is it greater than the journey length, so the distance? If that's true, we're going to get the current start location, set that as the swap. I'm going to get the current target location and make that into the current target start location, and then the swap now becomes the new target location. So effectively we're flipping the two vectors to make the platform travel back in the original direction. To determine direction, we're just going to get the current target location, and we're going to subtract the current start location to normalize it, and then that effectively gives us the direction to travel on. Okay, now that we've done that, the next thing we need to do is drive the platform forwards based on the direction towards its intended target location. So we've got the direction, it's been set there, so we're going to drag that in. We're going to multiply this by a float. We're going to drag from this, we're going to add another, so we're going to multiply a float by a float. And we need to set the speed. So currently I'm going to set the speed to 100, connect it to this. And last thing we need to do is, well, we need to make sure that we're adding this to the actual actor location. So right click, get actor location, and we need to grab this and set the actor location. So as you can see, it's got the direction, it knows the direction of travel, and it's just adding speed of 20 to each one. Now obviously you can see we've got 0, that won't move anything because that's what we're going to call in the delta time. So we're going to go here and we're just going to drag, bear with me, we're just going to drag that node straight in here, drag that down so it gives a bit of space, and there we go. So that's the last part of it. In terms of when the direction's been set, it'll basically move in that direction smoothly. Finally, we need to go into the last part of what happens when the platform hasn't reached its destination, and this is going to be a simple copy and paste. So select all of the nodes here, Control C, we'll go back to this boolean here, Control V. And what we're going to do is we're just going to drag it on the false here, connect that up to that. I'm just going to connect the delta seconds to the speed. So obviously I know that's quite a few nodes and it's a bit of a mess, but this project will be on GitHub for you to download if you need to just have a look to see what I've done. So finally we'll go on to the demonstration of this platform. Okay, so in the last part now we're going to demonstrate this moving platform BP in action. So I'm going to drag it into the world, I'm going to select the target location, and I'm going to make this move down. I might increase the speed just to demonstrate. That's to 150. Hit play, and as you can see, you have a moving platform that goes up and down. To show how customizable this is, I'm going to drag another one into the world, select the target location, and I'm going to make this into a diagonal moving platform. Let's have it going the other way. Hit play, eject, and as you can see, the diagonal moving platform is moving under. It's not constrained to any particular axis, it's literally just following what the designated target location is. So I hope you find this video useful, and let's say there will be a copy of this project on GitHub if you want to have a review of what I've done. Thank you for watching my video, and if you like what you see, please subscribe and like, and feel free to leave a comment below if you have any feedback or suggestions. Take care guys, goodbye.